Alright, back to make another video after so long. Hey, I apologize, alright? I got lazy and I procrastinated. There's no excuse. But at least I'm happy that I finished all of my finals, finished all of my classes, got a job, and right now during the summer, just summer work, and I guess more games. But I feel motivated again. So here I am, back to do another video, and hopefully this time I'll stick around much longer, continue to post a video a day. I hope. So wish me luck. But whatever. I kind of forgot what I did, so I had to went back to my channel and look at my last video. Last video was on deleting the first and last node, which is right here. And today we're just gonna do basically find the middle node on a linked list. Still Java. Here we go. So basically, in this video I'm gonna show two steps or two approach on how to do this. The first approach is the more friendly version. It's a lot easier to understand. At least that's what I thought. That's what I think. And it's more beginner friendly, I guess. Which is you count the nodes and then just divide the count by 2 and then find the middle. It would be the first. So what the first step would just be, you first loop through the entire list and count the total number of nodes, correct? And then afterward you divide the count by 2 and then loop again from the head and reach that index, the middle index, middle count basically. I'm just gonna write the code out, so it'll be probably easier to know just by looking at it. So node.find middle, something like that. First, we have a base case, which is head equals to. If head equals to null, meaning if there's nothing in the linked list, you just return nothing. Always gotta have a base case. First step, or step 1 basically, count the nodes. Very simple. We have int count equals 0, and then we have a node temporarily, and we're gonna place that on the head. While the temp is not equal to null, meaning if temp is not pointing at null, we increase the count by 1, and we look to the next one, which is temp.next. So temporarily would equal to whatever number is next. Step 2, boom, 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 you traverse to the middle. How this is going to work is you first have a middle index, which will be count divided by 2. You create temp again, but on the head. Yeah, again on the head. And then you create a for loop. So for int I equals 0, I is less than the middle index, and then I plus plus. So this is going to go through the loop again, the linked list again, and temp equals temp.next. And once the for loop is no longer true, you return the temp. And this part is basically the middle node. Now, I already wrote it down, the add, which is 10, 20, 30, 40, 50. And we got to do is just you print out the list dot find middle dot data. You play it should give you 30. Yep, 30. Now how it's gonna work? First, you count 1, 2, 3, 4, 5. It's gonna count. First step, right here. Count equals 5. Then second step would just be middle index, which is 5 divided by 2, which equals 2 with remainder of 1, but no one cares about the remainder. And then now you go into the for loop and and then you just follow it. It's true, so temp equals temp.next. So 20 is true again. So, temp equals temp.next, which is 30. So it'll be, how do I say? So the middle index would be 2, right? I equals 0. So it'll be from 10 to temp.next, which is 20. So temp equals 20 now. Now we have the I plus plus, so I equals 1 now. Still true. 1 is less than 2. So temp equals temp.next, which is 30. Now I equals 2. and this will no longer be true because it's not I less than or equal to. It's just I less than. So now that this is not true, this does not happen, and you just return the temp, which was still at 30, and that's why it prints 30. Now, if I had another number like 60, for example, oops, 60, for example, it's just gonna print 40, which because the count becomes 6 divided by 2, which makes it 3. So it just means you do the loop one more time, which would be temp from 30, temp equals temp.next, so it becomes 40, and then this no longer stays true. So now this method is very easy to understand. It's just clear, and you use it if you already have like a looping through the list for like a different reason and just want to reuse the count basically, right? But the downside compared to the second method, which I'm gonna use, called two-pointer approach. The downside of this is that it has to go through the loop twice, right? Whereas the two-pointer method, it only does it one time. You just loop it once and that's it. So it's kind of less efficient when it comes to a much longer list. This is very easy right now because it's just 6, but what happens if it goes to like hundreds or thousands of lists, then it becomes less efficient basically. All right, now that this is done, I'm gonna delete the first part. Now what we're gonna try to do is we're gonna do the two-pointer approach. So how this is gonna work is we will use 2 pointers. One pointer is going to be called slow, which only moves 1 step at a time. Whereas the second pointer is called fast, where it moves 2 steps at a time. So how it works is as they move through the list, when the fast reaches the end, the slow will be in the middle. Because the fast is like double the speed basically. It moves 2 steps at a time. An example would just be something like this. I can quickly show you before writing the code. So we have 10, 20, 30, 40, and 50. At the start, both slow and fast are equal to 10, correct? So it would just be, let's just write it 10, 10. On the first loop, or not really called the first loop, loop basically. Not looping through the whole list, but just looping through like the while statement. Slow becomes 20 because slow just moves 1 step at a time, while the fast goes to 30. On the second loop, the slow will just move 1 at a time again, while the fast goes to 50. And then the list ends, and it'll show you, and then you just gotta return like what the slow is, which is 30, right? So let's say if there was 60 though, then again it'll start at 10 and then 20, and then 30, 50. I'll just show it to you through the code. It's probably better that way. So first we have public void. We're gonna have again, find middle. First, we have a node, which is slow, and we're gonna have that pointing ahead. We have another node, which is called fast, pointing ahead. And it doesn't have to be slow or fast. You can just call it temp 1, temp 2. I'm just putting it this way, so it's probably a slightly bit easier to understand. So in the while statement, we're gonna have fast. So while fast is not equal to null, and fast.next is also not equal to null. Then slow equals slow.next, which makes the slow moves to the next one, and then fast equals fast.next. So this moves 1 step, while this one moves 2 step. And then when this while statement is no longer true, we're gonna check an if statement to check if the slow is not, to make sure if this is true. If the slow is not equal to null, meaning the slow isn't pointing at a null, then that means this is true, and we'll just print out the middle node. So middle node is, and then just slow dot data, something like that. And that should be it. So now I'm just gonna print out list dot print. We're gonna have first, let's try with an odd number. You know, oops, did I do something wrong? Oh, oops, why did I put print list? That was on accident. There it is, 30. So I think it shows basically the same thing. Both starts at 10. You know, fast is not equal to null, meaning, you know, fast is pointing at 10, not equal to null. Fast on next, which is 20, that's also not null. So the same is true. Slow becomes 20, fast becomes next, which is 30. And then you do the same thing. Is fast equal to null? 30 is not null. Is fast on next, which is 40, that's also null. So that's, you know, that's not true. So the while statement is true, meaning you do it again. So slow moves to 30, while fast moves to fast on next, which will be 50. Okay? So now fast is over here. You get the idea. Fast is over here. Now, reread, now again, back to the while statement. Is fast, fast is not equal to null. First part is true, but fast on next is equal to null, meaning this while statement is no longer true. And now we will go to this if statement and check. Is slow, if slow is not equal to null. That is true. Slow is not equal to null. You print out what the slow is, which is 30. Okay, and let's just, you know, increase the list a little bit. So let's say like 60. Yeah, I'm just gonna like copy and paste. Let's do like 80. Oh, not 800. I mean, I can, but you know. And 70, like that. So what's this gonna happen is now it has 8 nodes and it's an even number. Let's see how it's gonna happen, right? So let's just see how it's gonna work. So at the start, both slow and fast are 10, 10. The first move, everything, the while statement is true. So slow equals next, which is 20, while the fast equals 30, because it's fast dot next. Second move, you know, while statement is still true. So slow becomes 30, while fast becomes 50. And then you repeat this. So 40, 70. Gotta remember, because it's 50 plus 20. Okay? So 70. And then now when it reaches 70, you want, the next move would just be, when it reaches 70, it'll be, so it'll be right here, right, basically. Now you check. On the fourth move, it will still be true, because fast is not equal to null, and fast on next equals 80, which is also not equal to null. But the moment that because this is what happens next. The slow becomes slow dot next, which is 50, while the fast at 70 will equal to fast dot next. Fast dot next is 80, but next will be a null. No numbers is after 80. So this becomes the null, which is the end. Now it basically stops right here. This while statement is now no longer true. Now we just do the same thing. Is null not equal to null? I mean, is slow not equal to null? And that is true. So you print out what the middle node is, which is this right here, 50. The middle node. So on an even list, it would just show 50. Easy peasy. Yeah? Alright, well, you know, that's it for the video. Hopefully tomorrow I'll post another video, and you know, I don't know what's gonna be next. I kind of forgot what exactly my roadmap was. That was a little voice crack, but kind of forgot what my roadmap was. Gotta recreate everything, and you know, hopefully I commit to it again and not be a dumbass. Yeah, thanks for watching. See ya.